Good day everyone, my name is Ganesh. I'm from FKP from group 2. We are assigned to do question 2 and question 8 for dynamic assignment subject. Okay, I'm going to explain question 2, the first step of question 2 lah. So this is the question. I'll read the question for you. Bar AB has an angular velocity. The angular velocity value is 6 radian per second at the instant shown in figure 2. Okay, they ask us to sketch the location of instantaneous center of zero velocity of bar BC. And then the second one is compute the velocity of the slider block C at the instant. So we are going to find the A, do the A first. So to sketch, this is the FBD. So we need to draw the FBD first. To draw the FBD, and then after done the FBD, we need to sketch the location of instantaneous center of zero velocity. To sketch this location, we need to follow two conditions for velocity. The first condition is the velocity is tangential to the path, and then the second condition is the velocity must always perpendicular to the instantaneous center. So I use that two condition and I drawn this diagram. So for the second one, John will explain the steps to find the velocity of B and C.
I'm going to continue on question 2. Ganesh has explained to you about A, and I'm going to explain to you on how to do B. So as we can see, question B is about compute the velocity of the slider block C at the instant. Okay, first of all, as we can see this diagram here, we must find the angles in each of it. So as you can see, the angles inside are 45, 80 and 55. So and how can we find these angles inside here? So from this triangle here, we are given 45 degree, 10 degree. Okay, as we draw a triangle here, as you can see, this is a perpendicular. Okay, and from here we can see it is a perpendicular. So 90 minus with 10 degree, we will get 80 degree here. And then from here, as you can see, it's a perpendicular too, and then we divide 2 to get 45. So as we add in 45 degree, 80 degree, and we minus it with 180 degree, we can get 55 degree here. So from this data we have collected, we can use the cosine trigonometry rule to find the length from B to IC and C to IC. As you can see, this is the cosine rule. Okay, as you can see from the cosine rule, we have BC over sine 45, which is BC, this length BC to 45, IC to C over sine 55, which is this, opposite to the length, and equals to B to IC, this length opposite to 80 degree, so it will be sine 80. So as you can see from this, we can solve the first few length, which is IC to C. So we take BC, the length BC, as it is given in the question. We can see BC is 0.5 meter, so we just substitute here, over sine 45 equals to IC to C over sine 55. From this calculation here, we just do crisscross multiplication to get IC over C, which is 0.5792. Okay, and then from this information here, we substitute this into this, which is 0.5792 over sine 55, which is here, equals to BIC over sine 80 to find the length B to IC. So from this we can see the length is 0.6963. Okay, next what we must do is we must find the velocity at B. Why we are finding the velocity at B? Because B contains most of the information than at C. So as you can see, we can find velocity at B using this formula, which is angular velocity times with the radius. As you can see in this case, the velocity at B is equal to angular at AB, which is given the question 6 radian per second, times with the radius that we had just find in this cosine rule equation. So in this we are going to use RB to IC, which is the length B to IC, which we got earlier, 0.6963. Okay, from the formula we can see that angular velocity is times with radius. So we did that 6 radian per second is times with the radius 0.6963. From this we can get 4.1778 meter per second. So we got the velocity for B. And then to find the velocity at C, we must find the angular velocity at BC, at line BC. As you can see, we don't have angular velocity on the link BC, thus we have to find the angular velocity in line BC. So how to find that? So this is the formula to find angular velocity at BC, which is we had got VB just now earlier, and we use 0.5, which is the length of B to C. Okay, then from this we compute to get the angular velocity at BC. We will get 8.36 radian per second. So we use this information found here to calculate VC, which is what is the question is asking us to calculate. Compute the velocity of the slider block at C at the instant. So VC equals to angular velocity at BC times radius at C to IC. So the information that we had got from above here, which is angular velocity BC is equal to 8.36 times with the information we have got up here, IC to C, which is the length 0.5792. So as you could see, after the product of these numbers here, we could get 4.8421 meter per second. So this is the final answer for the question. So that's all for our explanation for this question 2 from me and Ganesh. Thank you.
My name is Roshiteng. I will describe about the answer about question 8. So first I will explain question 8 to you guys. The wheel shown in this figure has 40 kg and has a radius of creation of k not equal to 0.3 meter about its center of mass, and it is subjected to a torque of m equal to 9 theta power to 1/2 Newton meter, where the theta is in radians. So for this question, we need to do 4 parts. The first part is we need to find the mass moment of inertia of the flywheel about its mass center. Secondly, we need to calculate the kinetic energy of the flywheel, and then we need to determine the work done by the torque M. Lastly, we need to solve for its angular velocity when it rotated for 5 revolutions. So I will show the step. The first, if we want to find the mass moment inertia of flywheel about its mass center, we use the formula I naught equal to mk naught squared. For this question, the mass given is 40 kg and the radius given is 0.3. So we use 40 times 0.3 squared, we get 3.6 kg m squared. And to find the kinetic energy of the flywheel, we use the formula T equal to 1/2 I naught omega squared. From the I naught we found just now, which is 3.6, we use 1/2 times 3.6 times omega squared equal to 1.8 omega squared. This is the kinetic energy of the flywheel. And then, since the wheel is initially at rest, so our kinetic energy will be 0, and since it is no movement, so the work done will be 0, and the movement at the origin of x and origin of y will be 0. So W, O, X, O, Y do not work. And then we still got M, so M have a positive work. When the wheel rotates, we will get the theta equal to 5 revolution times 2 pi radian over 1 revolution, we get 10 pi. We use 5 revolution because just now the question has mentioned about this wheel has rotated about 5 revolutions, and then to get the theta per revolution, we use this formula and we get 10 pi. And then we need to find the work done by M. We will integrate the M respect to theta, and the integral will be from 0 to 10 pi. So we will integrate the 9 theta power of 1 over 2 d theta. So the answer we get will be the final answer we get will be 1056.52 joule. And then lastly, to find the angular velocity of the wheel, we will use the principle of work and energy. The formula is the initial kinetic energy plus the change of work done equal to final kinetic energy. So since the wheel is initially at rest, so the initial kinetic energy will be 0, and the change of work done is equal to 1056.52, which just now we found it. And then the initial work done is 0, so the change of work done is equal to 1056.52, equal to the final kinetic energy is 1.8 omega square, which we found on the first part of this question. So we use 1056.52 divided by 1.8, and then we square root the answer, we will get the angular velocity equal to 24.23 radian per second.